Okay, so my name is JD Kaiser, and this is my slideshow on the human exploration of Mars. So I chose to do this goal because I've always been fascinated with Mars. It's a really hot topic right now. There's definitely plenty of um, room for discussion about was there ever life on Mars? Could we ever colonize Mars? Could we ever go to Mars? Kind of thing. So when I was reading up on this, there was four goals that NASA came up with, basically like stepping stones for just understanding the planet and its climate and all that before we even talk about getting there. So goal one is to determine if life was ever on Mars. So obviously, to our best knowledge, all forms of life need water to survive, and there is evidence on Mars of near the poles of Mars of hypothermal vents, which could have meant like hot spots like there are in Yellowstone, where these areas where superheated water is coming up and then cooling off. And if that was the case, then that would be a good spot for us to look for life because that is kind of how life originated on Earth. Excuse me. We also want to look for any evidence of carbon, as carbon is an essential chemical for life. So those are two pretty big things. Goal two is to characterize the climate of Mars. What's the Martian climate like today? And the current Martian climate is regulated by seasonal changes of carbon dioxide ice caps, the movement of large amounts of dust by the atmosphere, and the exchange of water vapor between the surface and the atmosphere. One of the most dynamic weather patterns on Mars is the generation of dust storms that generally occur in the southern spring and summer. These storms can grow to encompass the whole planet. So these are just huge storms of rocks and dirt and ice just blasting at close to over 100 miles per hour in some cases. Just not a very good spot if we were to be on Mars. So that's one thing to consider. We'd have to understand the climate, like when the spring and summer times of Mars, like how would life adapt to that sort of weather? That'd be new weather that we don't experience really here on Earth. Goal three is to characterize the geology of Mars. How did Mars become the planet we see today? So we do know that there is evidence of volcanic activity on Mars, and even evidence of volcanoes that are 100 times larger than those on Earth, um, which leads to consider that if there was some sort of volcanic activity and water, then we know that in the ocean with those deep volcanic vents, that maybe some sort of life could have formed by those hypothermal vents that were generated by those um, volcanoes. And then goal four is to prepare for the human exploration of Mars. Obviously, eventually humans will most likely journey to Mars, and getting astronauts to the Martian surface and returning them safely to Earth is a very difficult challenge. So this is sort of let me skip through a little bit here. So this was just the climate, a little bit more on the geology, and then here we go. This is getting humans to Mars. So we'd obviously have to have more advanced technologies than we do now. Because how would we sustain life on the planet? We'd need some sort of habitat, or called a hab, where obviously the astronauts can live, and then getting food there. Would it be packaged food? Could we even generate some sort of food on the Martian planet? Like, there's a whole bunch going to this. So, um, sorry, excuse me. We do know that Martian soil contains super dioxide, which is basically they break down organic molecules. So I don't know if the Martian soil would be exactly able to support life. Uh, thank you.